In this question, we're told that a mechanical contraption is used to prepare metal for recycling. At first, the contraption can process 80 kilograms per hour. This is the first piece of information we can extract. A equals 80. We're then told that this increases by 7% each hour. This is the next piece of information we can extract. Our common ratio, R, equals 1.07. This is because it's a percentage increase, 7% increase. 100% add 7% is 107%, and 107% is 1.07 as a decimal. We are asked in the first part how much metal is processed in the 10th hour. The 10th hour singular, not the first 10 hours. We're not adding up 10 hours. We're asked specifically about one value, the 10th value. When it's singular, we use U. S is for the sum when we add up lots of them. Singular, we're using the single term U. For the sum, we use S, but this is singular. We're asked to find how much is used in the 10th hour. So we know that N is 10. I now need to select my formula. The formula that I need is UN equals AR to the N minus 1. I know this because it's the only formula that gives me UN for a geometric progression. Substituting in, I get U10 equals 80 times 1.07 to the power of 10 minus 1. If I put that into my calculator, I get this answer. In the question, I'm told to give my answer to 4 significant figures, so that would be 147.1. The second decimal place is a 7, which rounds the first decimal place up to a 1. The units are kilograms, just like they were for the first term. That's what the metal is being weighed in. So that's part A. Part A, 147.1 kilograms are processed in the 10th hour. In part B, we're told, the machine is run for 12 hours before being shut down for maintenance. Well, straight away I know that N equals 12. How much metal is processed in this time? In those 12 hours, that's 12 separate 1-hour slots. That's the sum of those 12 separate terms. S12 equals, well, that's what we're trying to find out. Well, we still know that A is 80 and R is 1.07. That's great. What formula do we want? Well, in this case, we need a different formula to the one that we've used previously because we're calculating something different. We need the formula Sn equals A brackets 1 minus R to the N, all divided by 1 minus R. If we substitute our known values in for this to find the sum up to 12, A is 80, R is 1.07, N is 12, and R once again is 1.07. If I put that into the calculator, I get a value of 1431 to 4 significant figures. I've rounded off after the decimal point. The 0 is small, the 1 stays the same, and that is still in kilograms. So that's part B finished. In part C, we are told that there's a delivery of 740 kilograms of metal, and we're asked how long it will take to process. It's going to take more than 1 hour to process that much metal, so we're looking at the sum of several hours. We don't know how many hours, but it's the sum of several of them. So we're being asked to find a sum. I've not specified what N is, because I don't know. In fact, I do know the value. S subscript n is not unknown. S subscript n is the total amount we're going to process. That's the 740 that we've been given. N is the unknown part. A is still 80, and R is still 1.07. The formula is still the same one as we had in part B. If we substitute in, Sn is actually now known. A is known, 1 is 1, R is 1.07, and N is still unknown. R is known. Now this requires a bit of rearrangement. So what I'm going to do is I'm going to get some fresh paper and continue. I'm going to simplify the denominator. 740 will be equal to 80, brackets 1 minus 1.07 to the n, but this is going to become minus 0.07. We can do that on the calculator if we prefer. The next step will be to multiply both sides by minus 0.07. 740 times by minus 0.07 is minus 51.8. And that's equal to 80, brackets 1 minus 1.07n. Next, I need to divide by 80, because this is currently being times by 80. And 51.8 divided by 80 gives us minus 0.6475. And that leaves us with the contents of the brackets no longer being times by 80, so we don't need the brackets anymore. There. Currently, this 1 is here. Now, it's having this taken away from it, but 1 itself is positive. To get rid of it, I need to subtract 1. And I'll just be left with this part. And if I subtract 1 here, I've got minus 1.6475. This is negative, and this is negative, so I'm going to simplify things. They're both positive. I could have achieved that by multiplying both sides by negative 1. Now what I need to do is find out this unknown index of n. To do this, I'm going to use logarithms. I'm going to take logarithms to a base of 1.07 for both sides. If I do this, I will find out that log to the base 1.07 of 1.6475 is equal to just n, because taking logs for the base tells us the index. Substituting this into my calculator, I have to use the button up here. And that gives me a value of 7.349. In the question, it asks me to give the number of hours to the nearest whole number, which is 7. And that concludes part C.